All right, this video is about section 9.2, which is related to horizontal asymptotes. So first of all, we need to describe what we mean when we say horizontal asymptotes. All right, so horizontal asymptotes describe the end behavior. Describe the end behavior of a specific graph. So in other words, a horizontal asymptote shows where the y values level off. Shows where the y values level off as the x values get increasingly large or as the x values get increasingly small. And so what we mean by that is if I have an xy axis, and let's say I know there's a horizontal asymptote right here. So there's this imaginary horizontal line, and as the graph goes way out to the right, okay, so as the graph goes way out to the right, maybe something like this, it's going to level off at that horizontal asymptote. And so that would be when x is going towards infinity, right? So the x values are getting very large. Or the other side of the graph, who knows what happens in the middle, and it doesn't really matter. Maybe it even crosses, I don't know. But then it's going to level off at that same place where we had that horizontal asymptote. And so over on the left side, that would be where the x values get increasingly small. So the x's are going towards negative infinity. So that's what a horizontal asymptote does. It shows you where the graph levels off either on the far right or on the far left. All right, so in order to find the horizontal asymptotes, we have these three rules, okay? And there's three different cases that can happen. Basically, you're going to compare the degree of the numerator and denominator. So you got to remember what we mean when we say degree. For example, if I have y equals, let's say, x squared plus 2x minus 3 over, I don't know, how about x cubed plus 2x squared minus 7x, something like that. So remember earlier this semester, we said that the degree is the highest exponent. So the degree on the top right here is 2. The degree on the bottom right there is 3. So this is a case where the numerator degree is less than the denominator degree. And so in that case, we would say that there's a horizontal asymptote when y equals 0. Okay? Well, it might be a case where it's just the opposite of that, where the numerator degree is larger than the denominator degree. An example might be y equals, I don't know, x squared plus 5 over x minus 2. So in this case, do you see that the degree of the top, the highest exponent, is 2? The bottom, this is like an x to the first. So the numerator degree is more than the denominator degree. So in that case, there are no horizontal asymptotes. And then, of course, hopefully you recognize the only other scenario is what if the degrees are equal? Let me make this a little bit smaller here. What if I have, let's say, y equals 3x squared plus 2 over 5x squared minus 3x plus 1. So in this case, the degree of the top is 2, the degree of the bottom is 2. So that means the degrees are the same. And when the degrees are the same, when the numerator degree is equal to the denominator degree, in that case, in order to find the horizontal asymptote, you take the coefficient from the numerator over the coefficient from the denominator. So in the example that I have written here, the coefficient in the numerator was the 3. Remember, the leading coefficient is out in front of that highest degree. So 3 over coefficient from the denominator. Sorry. The coefficient from the numerator is 3. The coefficient from the denominator is 5. So the horizontal asymptote would be 3/5. Okay? Now, keep in mind, a graph will never cross a vertical asymptote. But it can cross a horizontal asymptote. And kind of like The example I showed you up above, remember how I showed you as I was going out to the left, it did cross the horizontal asymptote right here. It's okay if it crosses there in the middle, because horizontal asymptotes talk about what happens as you go way out to the left and what happens as you go way out to the right. Okay, so if all I want to do is find the horizontal asymptote, okay, I don't care about graphing anything. If I just want to find the horizontal asymptote, then I'm going to compare the degree of the top and the bottom. In this case, since there's no x's on top, it's kind of like having an x to the 0. So the top is 0, the bottom is 1. So that's the first case. Numerator is less than denominator. So the horizontal asymptote, y equals 0. Okay, going to the right, do you see that in this case, the degree of both the top and the bottom is 1. So they're the same. So that's case number 3. So the horizontal asymptote is the coefficient from the top. Remember, the coefficient is the number out in front. So 1 over coefficient from the bottom right there is 3. So horizontal asymptote at 1/3. Last case, degree of the top is 1, degree of the bottom is 2, top is less, so y equals 0. Just using the rules in the box up above. Bottom row, I've got the degree of the top is 2, degree of the bottom is 2. They're the same, so the horizontal asymptote would be the leading coefficient, so 3 over 1, which is 3. Next one, the degree of the top is 0, degree of the bottom is 3, so the top is less, so y equals 0. And then on this one, even though they're not multiplied out, you can tell if it was multiplied out, that top would be an x squared, so the degree of the top is 2, degree of the bottom is only 1. Remember, when the top is more than the bottom, there are no horizontal asymptotes. Guess I don't need y equals none. Okay, so in general, that's finding horizontal asymptotes.